well, let's find something that doesn't require any soldering. Should be easy. And we looked and we looked and we looked and we couldn't find anything. So I said to him, well, you're going to have to invent it. So he did. So he invented Xinabox. Here, for example, is a weather sensor in the middle here. So this little guy in the middle of the moat, it will give us temperature, pressure, relative humidity. And using that data, we can calculate cloud altitude and dew point. All of the components are put onto these identical boards, and we use this connector. So every board is the same size. In fact, what we did for a bit of fun is these larger holes over here in the corners, they actually fit directly onto Lego. So, so what we did is we used the Lego standard, because Lego has got such a good standard. I've got a little screen over here and a little CPU, because we need to have a brain, and it can run Arduino, Java, Python, MicroPython, and as you can see, it's got a Wi-Fi hub at the back. So, so what I've done is I've put this together, and in fact, one can put it together in any format. What it'll do is it'll count down, and then it'll start displaying the data on the little screen, as well as on a data dashboard, a web-based dashboard. And we call each one an X chip. So we've got over 80 different X chips in full production.
We're back with another episode of the Cold Star Project, the podcast about scaling space companies. And we're here with Judi Sandrock from South Africa. She is far ahead in time than I am. So thanks for being here.
Oh, thank you so much. And thank you for getting up so early in the morning to accommodate.
Yeah, well, it's 9:30 my time. I was up early today. I already got my Make Space Boring video out, a little update about who I met and what I'm doing. And you will be in tomorrow's because we recorded this today. So you are the co-founder of a couple of different organizations, MEDO Space, which we'll get into in a second, and also Xinabox, which is very interesting. And the reason I wanted you on, first of all, South Africa is outside of the standard North American and European, centric areas of operations. So I love hearing voices from outside that area. I'm a Vancouverite originally. We had a quick chat before we got on here and recorded, and I've met a lot of South Africans who emigrated to Canada and enjoyed their company immensely. I quit drinking 8 years ago as of January, but back in the day, I used to, when I was running a metal fab shop, my foreman was South African, and I used to go over to his house, and at 5 in the morning or so, we'd watch the rugby championships that year.
Oh, yeah.
This was in the middle of the 2000s. I'd have a couple of beers. It would be pretty funny because it would be 8 in the morning by the end of it. I'd have to go home. Yeah. But so tell us a little bit about MEDO Space, what it is, and what you're working on achieving with it.
Oh, absolutely. Great. Thanks so much. To give a little bit of background and context, in my first life, I was a chemical engineer, and I was in the mining industry and pulp and paper industries for 22 years as a professional engineer. And when I left corporate in 2008, what I did is started the Meta Economic Development Organization, essentially for economic development projects, to roll out and implement economic development projects. We have a massive challenge, especially in South Africa. We've got close to 50% youth unemployment. Youth is 30 years and younger. So we have massive challenges, and our industry is really small. Our economy is small. So we don't have those huge job producers or employers as one does in much larger economies. So, so the idea was very much sort of, how can I, as a young person, become enterprising? How can I create my own job? And maybe at some point then, maybe I can also start creating jobs for other people, build a small business and create some jobs, create some employment so people can put food on the table, get kids to school, etc. And so the focus always was in rural areas, small towns, that kind of thing, away from the major centers. And after a few years, what we started to realize was that we actually had a STEM problem, because especially in outlying areas, the schools didn't have enough students who were interested in science, technology, engineering, mathematics, that they couldn't justify the teachers. So the thing is that on one hand, yes, we have a shortage of STEM teachers in South Africa, but on the other hand, a school in a small town, which only has, let's say, 200 students across what you would call a K-12, if you don't have 15 or more students who are interested in mathematics or who are going to select mathematics, the government cannot allocate a teacher. So what we realized was we had to create that inspiration, we had to create that interest, so that students would put their hands up and say, please, I want to do this, I want to do it. And we thought, well, there are two things that children really like, dinosaurs and space. Dinosaurs was going to be a little bit difficult, so we thought, space, let's do something in space. And so therefore in 2014, early 2014, one of our major sponsors, especially for our rural program, is Isuzu Trucks, a Japanese company. And they were very, very eager to develop STEM candidates so that eventually they would be able to employ engineers in their factories that they operate on the continent, on the African continent. And nobody knows what jobs those engineers were going to tackle, but we knew it was definitely going to be STEM related. That was one thing. And that also comes in with whole Industry 4.0, the fourth industrial revolution, etc. We knew that we had to focus on STEM, so they were very eager to sponsor the program. And surprisingly, they said, yeah, space, that's a great idea. So, and they said, yes, we're very happy. What we'll do is we'll sponsor the program, we'll pay for the whole thing, but really you guys haven't got a clue what you're talking about. So best you go and learn about something to do with space. So the first thing we did then in late 2014, early 2015, is we went to a number of satellite conferences. We purchased a CubeSat and a launch from one of the providers, because there was absolutely no way that we were going to go out to schools, especially underprivileged schools and schools in outlying areas. They'd been let down by a lot of people, and we weren't going to let them down. So we weren't going to go there and talk about space when we weren't going to put anything into space. So we needed the ticket to the game. It needed to be authentic. So yes, one of the first bills that Isuzu received was for a satellite and a launch. How they got it through the truck factory, I don't even want to ask those questions. But anyway, they paid. And at one of the first workshops we ever went to, we met Professor Bob Twiggs, and one of the inventors of the CubeSat format. And Professor Twiggs from Morehead State University at the time, and what they had is that they had a program that they ran in Morehead in eastern Kentucky to recruit especially young women to study at Morehead State University, to study engineering and hopefully space engineering. And this program that they ran was all around doing some electronics, measuring temperature, getting some data, putting together a payload on a large helium balloon, sending it up, getting a message using a radio, and in a way simulating a satellite so that they could then go on to design a satellite that could then be built by the university and go into orbit. So this really resonated well with us. We, through the process, we were introduced to Dr. Ben Malfris, who runs the Space Science Center at Morehead State University. And he introduced us to this program that they used to run. So that was really actually the first program that we started running. Morehead State University, Dr. Malfris said, please go ahead, take all the learning, take everything the way we do it, please be our guests. The more impact we can have in the world, the better. So what we did is we got two large, what are they, lorries? We call them trucks. But I mean, they're not pickups. You know, they're large. They carry like 10 tons of whatever, closed lorries. And we kitted them out as electronics labs, and we had teams that went to schools and all of that into really underprivileged areas, what we call townships, very underprivileged areas, and small villages and all of that kind of thing, taking the STEM program. And what the students were doing is that they were soldering together what they called a little jiggy bots that like moved around on the table with a coin cell battery. And then those students who were still very interested in it, then we would have a camp during the school break, where we would go away for a week. And then we would do these, what's known as a cricket sat project, where they would solder together a thermistor, and that would be connected to a radio, a software-based radio, and on the helium balloon, and collect the data, the temperature data, and draw graphs and all of that kind of thing. And that was a week, and then at the week culminated in parents and teachers and academics and media and everybody coming around for a presentation on what they'd done that week. And it really, I mean, there wasn't a dry eye in the room. Everybody was in tears, and parents were so proud, and it was really absolutely unbelievable. Up to a point, because we weren't getting enough impact. And when we looked at it, as a good bunch of engineers as we do, we realized that our main constraint was the soldering. I think you pronounce it soldering. We pronounce the L. And these solder irons. Students were getting burnt. It took a long time. There were a lot of consumables. We had a lot of restrictions because they all had to be plugged in, and we didn't want to overload the electrical system of a school that's in a rural area where maybe they've only got one plug point. Didn't work for us. So at the time, my husband had joined me in the business, in this non-profit organization, MEDO, Meta Economic Development Organization, MEDO Space. He joined me. He's an IT expert, software. It was software development, and he came from the background of assisting our constitutional court in South Africa, giving everybody access to legal information from a human rights perspective. And so he came and joined the non-profit, and and he's also an engineer. So when we realized that we had this constraint, we thought, well, let's find something that doesn't require any soldering. Should be easy. And we looked and we looked and we looked, and we couldn't find anything. So I said to him, well, you're going to have to invent it. So he did. So he invented Xinabox. Okay. So here, for example, is a weather sensor in the middle here. So this little guy in the middle of the moat, it will give us temperature, pressure, relative humidity. And using that data, we can calculate cloud altitude and dew point. And then over here, we've got a nice little light sensors. So we can do ultraviolet, and we can also do visible light. And all of the components are put onto these identical boards, and we use this connector. So every board is the same size. In fact, what we did for a bit of fun is these larger holes over here in the corners, they actually fit directly onto Lego. So, so what we did is we used the Lego standard, because Lego has got such a good standard. We thought, you know, one never goes wrong with Lego. So here we go. You know, everything works better with a little bit of power. And then I've got a little screen over here. Put that in. And a little CPU, you know, because we need to have a brain. We need to have a brain of sorts. So this guy over here has got a 4 megabyte memory, and it can run Arduino, Java, Python, MicroPython, and as you can see, it's got a Wi-Fi hub at the back. So you know, so what I've done is I've put this together, and in fact, one can put it together in any format. You know, it doesn't have to be like that. It can be, you know, put in any kind of format. It all runs exactly the same voltage. All runs I2C as a communication protocol. So what I need to do now is I need to add some power, because if I put it into my laptop, you're not going to be able to see it through the camera. So let me quickly find a power bank. Here we go. So there we go. It's powering up now.
Yes, I can see the little light.
It's telling me that it's address. It's looking for the Wi-Fi to connect to the Wi-Fi. What it'll do is it'll count down, and then it'll start displaying the data on the little screen, as well as on a data dashboard, a web-based dashboard. So, so this is really just a starter kit. Of what we call the weather station starter kits, and we call each one an X chip. So we've got over 80 different X chips in full production. So we have a GPS, we've got an accelerometer, a magnetometer, infrared sensor, gamma ray sensors, multitude of them. We've got different power solutions. So instead of using USB, you can have coin cell battery or solar power, AA battery. We've got different CPUs. We don't have to use this one with the Wi-Fi. We have Bluetooth. We have a long-range radios. We have a global star chip, all of that kind of thing. So what we did is we started using these X chips. I don't think you can see it here, but the data is also starting to display on.
We can see the display. So,
yeah. So the thing is, what you can do is you can run around outside and indoor and compare the data and all of that kind of thing. And what we've done is we've done it in centigrade as well as Fahrenheit, so that we can engage everybody in the world. You know, not just imperial or metric. So in August 2016, my husband Bjarke, so you know, our inventor, Bjarke Gottfredsen, he is Danish, so that also explains the Lego, you know. So what he did is he went with the specific purpose of showing Xinabox to Professor Bob Twiggs.
Hey, this is Jason Kanigan, the host of the Cold Star Project and the founder of Cold Star Technologies. I've decided to do something new. I've started doing daily update videos on who I met and what I learned the previous day in the space field. And it's a great sort of follow me thing. You can learn what I learn. I'm meeting a heck of a lot of people and learning a lot of things really fast. And the space field is really disparate. There are tons of nooks and crannies to go into and explore, from legal, operational, you know, regulatory, compliance, and gosh, the end customer. Who'd have thought about that, right? So you can sign up for this. If you go to coldstartech.com/MSB, that's short for Make Space Boring, the mission we're on, then you can sign up, and in your email you will get a daily notification that the new video has been posted. I'm also thinking about doing some branded mini courses and summarizing papers as I'm able to. So those will be some goodies that are in there as well. So if you're interested in that, go to coldstartech.com/MSB and join us on the mission to make space boring. Now back to the interview. And Judi, these are, for those who can't see, who are listening on the audio, these are what, 3-4 centimeters square, something like that?
3.2. Okay. So it's 32 millimeters by 32 millimeter squares.
See, there's my metal fab shop estimation skills still
brilliant,
around
brilliant.
after 10 years. Yeah.
Absolutely. And yeah, they're white and black. And what we did is we stuck to the black and white with no color, because the students, they want to work with the real deal. They don't want to work with a toy. Also, the thing is that Xinabox is very popular in universities, technical universities. So the thing is, we didn't want the university students to feel, I'm getting a toy, you know, am I going to be able to use this in the workplace? It's across the entire board. Yeah, and also the thing is, we didn't want to go with the normal green PCBs, you know, because that kind of reminds us of soldering and being a little bit too analog. So we've gone for the white and the black. Anyway, so yes, so Professor Twigg saw these and he said, this is ideal for the ThinSat program. Because the thing is that he'd been able to secure funding for a new satellite format, which is a ThinSat, essentially a slice of a CubeSat. And but he needed something that was going to be very low cost, firstly, because the only altitude he could get was around about 200, 250 kilometers, which meant that the mission was going to be like 5 to 10 days. So one can't have a satellite that costs $100,000 to build if it's only going to last 5 days. It had to cost like hundreds of dollars rather than thousands of dollars, and which is the case with X chips, because we're a very low end disruptor. It's got to be affordable so that a rural school can keep their tech. One thing we will never do is we will never, ever, ever take something back from a school. If we go to a school and we do a project, the kid stays with the school. So we had to have a very, very competitive pricing points. Yes, so Professor Twiggs was very, very, very eager, because the thing is, what he wanted is he wanted to relate what was happening on the satellite with what was happening on the ground. So he wanted to have a 3-phase program. We did something in the classroom, like, for example, using this light sensor and this weather sensor. Then take these same sensors, put them on the helium balloon up to, you know, whatever, 30,000 feet, something like that. Then measure the altitude difference, the temperature differences, you know, what happens with the light, what happens to the UV index as we go through the clouds, etc., etc. You know, also, because it was Xinabox, we could put a GPS onto it, which means we could recover them. You know, a multitude of things that we could do in a second phase of the program. And then with the ThinSats, it's exactly the same sensors that we have on this light sensor that actually go on the satellite. And it's actually the exact same X chips that go, and we use the same connectors. So the tech is all the same. No, we're not going to send the screen. We're not going to send this Wi-Fi unit. So what we did is we had a global star radio. So we had the output so we could get the data off. The power solution, of course, was different. You know, that was a rechargeable battery with solar panels, etc. With the satellites, we had infrared. We had infrared sensors, and also the satellite frame, the aluminium frame. What we did is we had 5 temperature sensors on the frame because we were going to deorbit relatively soon. Our satellites were still going to be running when they heated up on re-entry. So we wanted to collect some of that data, see who lasts longer, the radio or the temperature sensor or the battery or everything. So yeah, that is how we got involved in the ThinSat program, and it developed from there. Our satellite itself that we purchased with the Isuzu's money, we purchased it from a startup rocket company, so they still need to launch, which is fine. We knew that it was going to take time, but in the meantime, we've been very successful in terms of over 40 ThinSats with X chips were launched in April this year, 17th of April 2019. The next ThinSat mission is November 2020. In February next year, with Quest for Space, a US-based nonprofit foundation, we're going to send a payload to the International Space Station, so students can collect data on the International Space Station. And as I chat with you now, there is a young man with 2 of these weather station kits on his way to Antarctica. And so what he's going to do is he's going to set them up on the South African base on Antarctica and then connect it to the internet so the students can actually compare their kit that they have with them in the classroom with what's happening on the base in Antarctica, all of that kind of thing. So yeah, I have to say, suddenly we realized we had a business. This wasn't just about doing outreach programs in South Africa. Now we were involved with Virginia Space through the ThinSat program, and they were rolling their program out in 5 of the US states in the Appalachian region. There was a lot of interest from Georgia, a lot of interest from California, the UK, United Arab Emirates, from Turkey. So we realized, wow, this is the real deal. And so we brought a 3rd shareholder and investor on board to run this for-profit business that now was starting to build itself. So what I do is that I still look after the nonprofit side. I still look after the outreach programs. And then the other 2 partners, we're all equal partners. We each have a 1/3 of the business. And then my husband, who's one of those partners, and then Daniel Berman, our 3rd partner, they very much look after the for-profit business, which involves manufacturing, it involves prototyping, getting the product into the distributors, global distributors, because the product is now purchased all over the world. By schools, universities, even businesses who want to do rapid hardware prototyping. They buy our X chips.
Well, this is fascinating. I had no idea that is what it looked like until you just showed it. So you were very clear about the values and the outcomes that you wanted, and you sort of iterated forward into a couple different solutions and then came up with this one. And I really do like the white look of it. And that it is different from that green circuit board style that you see out there. And it's sort of, there's something very straightforward to understand about it, that this clips together and you can configure them how you want. It's a kid could understand that quite simply. On a business side, I'm curious, so that, how do you sell these internationally? Are there any import duties that companies or countries charge, or is it fairly straightforward?
No, it's not. No, it's not straightforward. But
Didn't think so.
and that is one of the reasons why Xinabox is incorporated in Ireland. Is because the Irish business laws are the most up to date in dealing with tech companies, with intellectual property, etc.
Right.
So what we've done is we've trademarked it. A lot of people ask if we've patented it, and that was terribly shocked when I say no. A patent's only as good as how much money you have to defend it. So we weren't going to worry about patenting it. What we have done is we've designed the next version, and that is patented. So if we feel that we are being imitated too much, that it's really starting to impact us and encroach on our business, then we'll simply bring out version 2, which is patented. So we've done that. Then what we've also done is we've been very lucky. We've been able to engage with global distributors, RS Components, Mauser, Farnell. And so what it is that they take our product into their warehouses, their global warehouses, and then they distribute, they sell via their websites as they would any other electronics. So they are the large electronics distributors. And another partner another partnership we've been able to establish is with Microsoft Education. So what we have done is we've made sure that all of our kits, especially those kits that are going to be going into schools and universities, that they're compatible with Microsoft Education and Microsoft Azure, because it's full Internet of Things, because these are the things of Internet of Things, these X chips. And we support end-to-end IoT. And that was very attractive for Microsoft, because what it was is that the students could do very practical projects in the classroom, generate the data, and then actually apply a lot of the data science concepts, big data concepts, artificial intelligence, machine learning, all of that kind of thing. So we have a situation where Microsoft take us in to the marketplace. So, for example, Microsoft have introduced us into the United Arab Emirates at a senior government ministry level. And then also what they've done is that they've introduced us to a number of the value-added resellers in the education sector, who will then, they take the X chips and then they build their own project for them, lesson content and all of that kind of thing around it. And then they wrap it in this huge offering, which they then take to market because they're already well established in those markets. So as far as possible, we try not to sell directly. In the case of the ThinSat program, what we did is we sold our X chips to Twig Space Lab, who then incorporated it into the whole ThinSat program. They did their own lesson materials. They had the satellites built, integrated, all of that kind of thing. We didn't do that directly. We were simply one of the suppliers to the program. So yeah, we're not geared up actually to sell directly. We're very bad at it because it's tough. The whole thing about understanding the customs and the rules for every single country, and how do you import, and what duties do you pay, and getting and dealing with customs agents and all of that. They're distributors who do that. That is their role. That is their core business. So what we do is we engage with them in terms of getting our product out there. So we do a lot of the marketing ourselves, sure. Being engineers, we've got a lot to learn on that side, but thank goodness Daniel's not an engineer. So he brings a lot of that business experience and expertise with him to the fore.
Did you know that the smallsat industry has a 40% and greater partial and full mission failure rate? That's terrible. And yet I find most people in the space industry try to treat this as if it's no big deal. They don't even want to acknowledge it. And I think that's ridiculous. If anything, anywhere else was having a 40% or greater failure rate, trying to turn your car on, right? If your vehicle or your cell phone didn't work 4 times out of 10, 2 times out of 5 that you tried it, you would go berserk. And you would do everything you could to make sure that it got fixed. The Smallsat Process Engineering Department at Cold Star Technologies is all about showing you how to manage processes better, to eliminate the causes at the root that create these partial and full mission failure rates. And you don't need to hear it from me. You can look this stuff up in studies. It just comes out of what you might think are the dumbest things. Oh, I know that. Well, to know but not to do means you don't know it. You rush the production schedule, you don't manage it right, you don't have the project sponsorship set up quite right, and the resources aren't there. You've got this mission launch date that's moving, and you just throw the schedule out the window. 1/3 to 1/2 of your project schedule needs to be for testing. And yet, this is the first thing to get smashed in the head by a wrench. As soon as the monkey wrench is thrown into the operation, testing time goes out the window. If you want to avoid this problem, the answer is not more physical engineering. It's not. More engineers are not going to solve your problem. You have tons of engineers. I am not going to tell you how to engineer a satellite. I've got Dr. Rick Fleeter and other people on my team for that. And we're not going to come in there and tell you how to engineer it. But on the process side, and I have had engineers on this show say, engineers don't know nothing about processes. That's not me saying it, it's the engineers saying it, but I will definitely echo it. If you want to have a manufacturing process that ensures that your small sats, CubeSats get up there and work, come talk to us at Cold Star Tech. So if somebody's at a college or university or even a public school and they want to get involved, what is the best way for them to connect with you and find out where they can buy locally?
I have to say, I mean, our website is very, very informative, which is all one word, xinabox.cc. And, or otherwise, just if you just search for Xinabox, you'll be able to come to our website. And then what we'll do is then we'll point you in the right direction. What schools and universities or colleges can do, we have got a Shopify website, so they can place an order on that on our shop. We will simply fulfill it using a local distributor, the closest distributor to them. So, if it's in the US, it'll probably be Mauser or Amazon. In fact, if it's global, could be Amazon. If it's Europe, UK, Africa, it'll be RS Components, etc. So we've built that in. Into the engine where it'll pick the most suitable distributor to then fulfill those orders. Also, to be very open about it, for educational institutions, we certainly give a lot of support and we do give some discounts. So I'm very happy if people just want to just click on the contact details on the website or whatever, or get hold of me on my email address. I can certainly set up something where I can set up a discount for them that they could then use when purchasing. I can also introduce them, because in a number of the countries, the local distributors, they will have an outreach program that they would be very happy to support. So, there could be local corporate social investment funding available to support the program. And also, we have done a lot of lesson materials ourselves and experiments, which we've put together. We've got video tutorials, all of that kind of thing. So, and all of those are available on our website, free and open for everybody.
Okay, xinabox.cc. Not .com. .cc.
No, I wish. .cc.
All right. I just wanted to make sure people heard that. And I'll drop a couple of links to pictures of the components, the boards, in the description of the video and or the audio podcast.
Oh, that'll be great.
So yeah, people can pick that up or to have a look without, I mean, they can go to the website as well. Did we miss anything to talk about? I'm looking at my list of questions over here, and in the process of telling us the story about Xinabox and MEDO Space, you've answered them all. I have answers to them all. Is there anything we missed?
I think I have. I think what I'd like to do is I'd just like to bring it round again to sort of Industry 4.0. The future of work. That was really the founding principle, is how can we equip youngsters for the futures that they're going to have, so that they can thrive and have marvelous, meaningful, dignified work. And also what is absolutely crucial to us is to remove barriers. So we had to make sure that we could go and we could run a program anywhere. We didn't need access to internet. We didn't need a great electricity grid. We didn't need soldering irons. We didn't need a lab. All of the components are pre-calibrated. We've also developed a lot of the code ourselves, so that students can get going quickly. They don't have to learn how to code in Arduino or Python. As soon as they start getting results, then they can have a look at the code and say, oh yeah, I could tweak this myself a little bit, or actually I could write this kind of thing myself. Maybe I want to do another experiment, and maybe I actually want to write or compile the code myself, that sort of thing. So we've got a lot of coding examples and libraries, because that's fundamentally what we want to do, is we want to remove barriers. And we've certainly been recognized for that. In 2015, our program was nominated by the World Economic Forum as having the most impact on student education and gender equality on the African continents. Because what we do is we really focus on access for young women. We don't exclude the young men, but we make sure that the young women have access, because sometimes that can be very, very, very difficult in traditional communities. But that's a whole other subject. And I'm not a social anthropologist, so So yes, we were recognized by the World Economic Forum, and also we've been recognized on CNN in 2017 as having the most innovative projects coming out of Africa. And 2 months ago, we were recognized by BBC. They came all the way to South Africa, I think also just to enjoy Cape Town as well. Why not come to Cape Town? And so what they did is that they did a very nice documentary on what we were doing in schools on the African continent, as a feature an annual feature on BBC, giving access and equipping youngsters for the future. So I think that what we've done is we've made sure that we stay true to our principles and true to our cause. And the more X chips we can sell, the more we have economies of scale, so the more we can do. That's the way we look at it. Right.
Well, this has been really amazing. I've learned a lot. I've enjoyed the heck out of it, and seeing the chips has been eye-opening. It's like it's really straightforward to clip the chips together and start working with it. So, and to hear about the impact you're having is really tremendous. So, my guest today has been Judi Sandrock. She's co-founder of MEDO Space and Xinabox, and I highly recommend that you go check that out. Thanks for being here today, Judi.
Oh, thank you so much for the opportunity.